Number 4. Find the HCF of 75x cubed y squared z and 60x squared y cubed z squared. Solution. So we have 75x cubed y squared z, and we have 60x squared y cubed z squared. Now, this is what we have. Looking at the numeric part, we have 75 and 60. Now we are going to look at number that can divide both 75 and 60 without any remainder, from the simple to complex, that is from smaller number to bigger numbers. So now 75, 2 cannot go because 2 is not a factor of 75, but 3 can go. We can have 3 here. 3 can also go in 60, so we use 3. 75 divided by 3, that is 25. So we have here 25 x cubed y squared z. Now 60 divided by 3, we have what? 20. So we have 20 x squared y cubed z squared. Now, what's the next thing to do? Looking at the numbers, 25 and 20. What is common also? 5 can go in both. 5. 25 divided by 5. What do we have? That is 5. So we have 5 x cubed y squared z. Now, 20 divided by 5. What do we have? 4. So we have 4 x squared y cubed z squared. Now, looking at 5 and 4, we don't have any factor that can go in 5 and 4 again without having a remainder, except 1. And we are not interested in 1. So we go to the non-numeric part. Now, looking at what we have here, x cubed y squared z and x squared y cubed z squared. It is obvious that x is common, so we use x. Now, dividing this by x, what do we have? 5 x cubed divided by x. It will remain x squared. So we have 5 x squared y squared z. Now, this side, if you use x squared divided by x, what will you have? It will remain x. So we have here 4x y cubed z squared. Now, we still have x. We still have x inside. So x is also common to both. We use x to divide also. 5x squared, that is x squared divided by x. What will you have? X. So we have 5x y squared z. Now, we have x here. 4x divided by x. X will cancel x, remain 4. So we have 4y cubed z squared. Now, we don't have, x is not common to both again. Let's go to y. Y is common. Using y, dividing this by y, what do we have? Y squared divided by y, we have y. So we have here 5x y z. Also, y cubed divided by y, what do we have? We have y squared. So this is going to be 4y squared z squared. Now, y is still common to both. It's still common. So in that case, we use y again. We use y again. Now, y divided by y here, what do we have? 1. So in that case, we have 5xz. This y will go. Now, y squared divided by y, we have y. We still have y left. So that will be 4yz squared. So in this case, looking at y, we don't have y as a common factor to both again. Now we consider z. Now looking at z, z is common to both. 5xz divided by z, what do we have? 5x. Because z will cancel z. Now, z squared divided by z, it remains z. So what do we have left here? 5yz. So in that case, looking at Z again, do we have anything common for Z? Z is not here, Z is still here. So we don't have Z as a common factor again. And now, in this case, we cannot get our HCF, that is the highest common factors of 75x cubed y squared z and 60x squared y cubed z now. Z squared rather. So, we can now conclude that HCF of 75x cubed y squared z and 60 x squared y cubed z squared is equals to what? Is equals to the product of what we have here. It's equals to that product, which is from here 3 times what? 5 times x times y times z. And this is equals to what? 3 times 5. What do we have? 15. 15 times x, 15x. Times x, 15x squared. Times y, we have 15x squared y. Times y, 15x squared y squared. Times z, now we have 15x squared y squared, because this is x squared, y squared, then z. So it means that the HCF is 15x squared y squared z. That is the solution.